Today we're going to talk about polars. Now, compared to Cartesian graphs, which are x and y, polars has a variable theta included in it, and the function is r, and the angle is theta, where r is the directed distance from the origin to a point. But polars is also related to the Cartesian through x and y, because it's like you go out and then you go up to the point. So that's y and that's x. Now sine of theta equals y over r, so y is r sine theta. And then using the same thing, you could find x equals r times cosine theta. Alright, for the derivatives in polars, we could easily take the derivative of r of theta, which is the function for it. But on the graph, we need an x and a y. So to do that, to get dy dx, you do the derivative of y in terms of theta over the derivative of x in terms of theta. And the theta part would cancel out, leaving you with dy dx. For the second derivative, d squared y over dx squared, that would be the derivative according to Cartesian in terms of x of dy dx, but then we need it in terms of theta, so we take dy dx and d over dx and do d over d theta over dx d theta of dy dx, and then that would give us d over d theta of dy dx over dx theta. To find the area in polar stuff, area equals 1/2 integral from alpha to beta, so as to differentiate from a and b in regular Cartesian of r squared d theta. And that's pretty much area. You'd just plug in r, but some graphs might overlap when they're graphed, so it'd be kind of like this, where the overlapping area is right here. Alright, a common problem on Calculus BC exam is intersecting area, and two functions we can use is r equals 3 and r equals 4 minus 2 sine theta, which in a calculator and graphed would look like this. That's r equals 3, and this is r equals 4 minus 2 sine theta. Now for area of 4 minus 2 sine theta would be this section where they intersect, and it's given that they intersect at the point pi equals 6 and 5 pi over 6. So that's the area for 4 minus 2 sine theta, and the area for r equals 3 is out here. So it would be like from 5 pi over 6 to pi over 6, or you could take the entire area of the circle and subtract from pi over 6 to 5 pi over 6. The equation for the intersecting area would be area equals 1/2 integral from pi over 6 to 5 pi over 6 of 4 minus 2 sine theta 1 squared theta plus integral from 5 pi over 6 to 13 pi over 6 of 3 squared d theta, since we're going back around.